Hello students, in this session let us see the procedure for bituminous mix design using Marshall stability method. So design of bituminous mixes involves the following steps. The first step is for the selection of aggregates. You have to choose which is the nearest quarry to procure the material and do the aggregate gradation as per the requirement, and we have to determine the specific gravity of various aggregates, and the proportioning will be done so that the gradation of the taken aggregates will meet the requirement as per the MOTH specification. So these steps were already discussed in the previous session. In this session, we'll see how the bituminous mixes sample will be prepared for using the Marshall stability method, and determination of the various volumetrics, and finally how the optimum binder content will be determined using Marshall stability mix design will be understood in this session. We have already learned that aim of any bituminous mix design is to determine the properties of aggregates and the proportion of various materials that are used in the bituminous mixes, and the what mix you will get that should have sufficient stability to satisfy the service requirement. It should have a sufficient bitumen to ensure a durable payment, and sufficient wort should be there in the compacted mix so as to provide a reservoir space for the amount of additional compaction that is expected due to traffic, and the mix what we prepared that should possess the sufficient flexibility and it should be workable, and overall the mix what we prepared that should be stable, durable, and should produce a skid resistant pavement. Keeping all these things in the mind, will determine how the proportioning of various material will be done using the Marshall stability test, and we will also determine the percentage of bitumen, that is nothing but the optimum binder content to produce the stable mix. Let us first look into how the specimen will be prepared for the Marshall stability test. So for preparing a specimen, we require a moulds of 10 centimeter diameter and 6.5 centimeter height. That should consist of a base plate and a collar, so that any additional material will not be wasted during the compaction, and it should consist of the interchangeable base plate, and the collar can be used because when we compact the Marshall stability specimen, the compaction has to be done on the both side. That's why we are making use of the interchangeable base plate and the collar. And for the compaction, the prepared mix will be placed in the mold, and it should be compacted using the rammer for about 25 number of blows on each side. Okay, first compact it on the upper side, then reverse the collar and compact it again for 75 number of blows. So for the compaction, we generally use a hammer of 4.54 kg and height of fall is 45.7 centimeter. And while compacting the mix, you have to ensure that the compaction temperature for the mix is 135 degrees centigrade for 60 to 70 grade of bitumen. And finally, the compacted thickness of the specimen should be 63.5 plus or minus 3.0 percentage. If the compacted thickness achieved, if it is not under these limit, then the suitable correction has to be applied for the stability value what we have obtained. How that corrections will be applied, that we will look further. And now the standard size of the thickness of the compacted specimen should be equal to 63.5 plus or minus 3 mm. Next is the preparation of specimen. So to prepare one specimen of Marshall stability, we require around 1200 grams of aggregates, and filler materials is required. So these material, okay, so when I talk about the aggregates, that consisting of both coarse aggregate, fine aggregates and filler material. So all together we require to prepare one sample, we require 1200 grams of material. So you can see here all the aggregates of various sizes I have taken, and this will be proportioned as per the proportion what we obtain in the Rutherford's method, and weigh the material, and the individual all the material must be first heated to a temperature of 150 to 170 degree. Temperatures play a vital role in the preparation of the bituminous mixes. It is very much essential to maintain the temperature during mixing, during compaction, and also during the laying of the bituminous mixes. Now all the aggregates what we have taken, that must be heated to a temperature of 150 to the 170 degree. And in the separate container, you have to heat the bitumen to a temperature of 150 to 165 degree, and the amount of bitumen to be added will be dependent upon the requirement. So generally on the first trial, you will consider some, let us say first trial we will start with the 2% of bitumen. In the next trial, it has to be increased to 2.5 or 3% or 4%, 5%, etc. Okay, on each and every trials you need to increase the percentage of bitumen that we have added, and then using that results what we obtain, we have to find out the optimum binder content or OBC, which will give you the maximum stability and flow value. The both heated aggregate and the bitumen are mixed together at a temperature of about 165 degree, and then it will be filled into the mold. And while compacting, you have to ensure that the temperature of compacting specimen should be around 100 degrees centigrade to 145 degree centigrade. Okay, after the mixing is done, transfer the material, bituminous mixed material into the mold, place the collar and apply 75 number of blows on either side of the bituminous sample and compact the mix. The compacted specimen is then extracted out, and for after 24 hours, that is ensure that the complete cooling of the bituminous mixed material will be done. That sample what we have prepared, the compacted specimen, has to be extracted. You can use the manual extractor or Marshall machine. You have extractors will be provided. Any of them using the manual extractor or the Marshall machine, you can extract the sample. And then the sample has to be heated to a standard temperature, testing temperature of 160 degree or plus or minus 160 degree. This can be achieved by immersing the bituminous mix sample in the thermostatically controlled water bath for about 30 to 40 minutes to ensure that standard testing temperature will be attained into the bituminous mixes. After the temperature has reached 60 degree, take out the specimen from the water bath and place it below the breaking head of the Marshall testing. The load is generally applied at a rate of 5 cm per minute. After the completion of the test, we will have the load value and then the deformation value. Using those two, we will be going to measure the stability value. The two outputs that what we are obtaining from the Marshall stability test are, the first one is the stability value, and we have to measure the flow value. The stability can be defined as the load taken by the specimen at failure. Okay, before the breaking of the specimen, how much load the given specimen will take, that will gives you the stability value. And at this point of time, what is the deformation of the specimen, okay, that will define the flow value. Thus, stability is the load taken by the specimen at failure, and flow value is the deformation of the specimen at failure. For the stability value what we have obtained, this correction can be suitably applied if the height of the specimen is different from 6.35 centimeter. I've already mentioned that if the value, the thickness of the compacted specimen If it is varying other than 63.5 to plus or minus 3 mm, then the suitable correction has to be applied. So we'll see how the Marshall testing machine looks. So this is the place where this is the crushing head. Okay, so the load is applied. To measure how much load is there, we have proving ring is attached to the loading frame, and you can see here this is the dial gauge. Dial gauge will measure the deformation of the specimen. So now the prepared specimen has to be placed. So this is the direction in which you have compacted the specimen, but when the testing is done, so the specimen has to be placed in the perpendicular direction to the direction where original compaction has been done. And after placing the specimen into that Marshall stability testing machine, gradually the load has to be applied. And for frequent load application, you will have to measure what is the deformation that is there on the bituminous sample. So when we apply the correction, so this table here will gives you the correction factor. If the approximate thickness value, you can see here the one, there is no correction if the compacted thickness value is 63.5 mm. If the correction thickness value is between these two values 61.9, then the correction factor will be 1.4. Similarly, if the thickness what we have obtained is 57, correction factor will be 1.19. And if the thickness value increases, the corresponding correction factor value will be given. So now the stability value what we have obtained for the given for the compacted thickness, that has to be multiplied by the suitable correction factor value to get the corrected stability values.